Hooke's law relates the force applied to a spring and the displacement of that spring. The proportionality constant used to make this proportionality into a useful equation is called the spring constant. Its units will be determined from the units of the force and the displacement. Here you can see the data for my first spring. I have my original data listed, then beside it I have converted the displacement in centimeters to meters by dividing the cells in column A by 100. The force values are just the weights of the different objects, so the mass was converted to kilograms and then multiplied by 9.8 meters per second squared to get weights in newtons. These latter two columns are then used to get a graph. I exclude the displacement for the object with unknown mass because I do not know its mass and thus weight. Instead, once the graph is created, you can get the weight from the graph by going to the displacement caused by that object, use a straight edge to move up to the line fitted to the data, then use a straight edge to move over to the weight axis. From the value you get on the weight axis, you can then convert that to the mass of the object by dividing by 9.8 meters per second squared. After determining the mass from the graph itself, check your answer using the equation provided by Excel, assuming you use Excel to do your graph. For the second spring with a different spring constant from the first, one simply repeats the same process. Convert the displacement and mass values to displacement in meters and weight in newtons. Plot the known pairs and get a fit to the data. Then use the displacement caused by the object with unknown mass and a straight edge to move to the line and then over to the weight axis to get its weight. Convert that to kilograms. And check your results against what the equation Excel gives. The first spring is then to be used in the gravity field of the moon. The moon has a different acceleration due to gravity, so the displacements are different for the same masses, but the process is the same. Convert the displacement and mass values to displacement in meters and weight in newtons. Plot the known pairs and get a fit to the data. Then use the displacement caused by the object with unknown mass and a straight edge to move to the line, then over to the weight axis to get its weight. Convert that to kilograms. And check your result against what the equation Excel gives. Do not forget that you should be using the moon's acceleration due to gravity in the conversion of mass to weight, and then weight to mass. For the last part of the lab, you're supposed to use the wave equations located in Chapter 10. Section 10.7 has wave equations for displacement, velocity, and acceleration. Use your data to fill out values for the amplitude and angular frequency to create equations that you can use to create graphs. You are to create data from these three equations for twice the period value that you found. The time column can start with 0. The cell below the first one would contain the equation equals A2 plus 0.1, which should produce 0.1 in the second cell. This can then be copied down until the time column contains twice your period values. The next three columns would be your completed equations for displacement, velocity, and acceleration written to reference the cell for the time for that row. As you copy each of these down to match the time column values, you should see values of displacement, velocity, and acceleration appear. To complete the graph, you can create a single graph for each wave equation by choosing the time column and the column with the wave equation you want to plot. You can use the scatter plot smooth line fit option to create the graph. That would produce 3 separate graphs. Make sure to title each properly and include axes labels. Alternatively, you could choose all 4 columns and plot them together as shown in my data sets. This plot can be used to easily compare, for example, the maximum displacement to what the values of the velocity and acceleration would be at that time when the displacement is maximum, or find the time when the displacement is 0 and determine the values of velocity and acceleration at that time. Either of these options for plotting this last data set is acceptable. What you will submit in your Word document lab write-up. In addition to answering the questions and providing completed data tables, there will be 6 total graphs that need to be properly done and appear on their own pages, filling that page. So, proper title for the graph, proper axes label, A line fit to the data extended to the y-axis as appropriate, and if you use Excel, an equation for that fitted line on each graph. This will not be necessary for the wave equation graphs. The last three graphs can be three separate graphs or one that combines displacement, velocity, and acceleration. And you should have a calculations page that includes each of the calculations specified in the analysis section of the write-up.